Hi guys, how are you? Today we'll keep going with the AB calculus, and I believe more problem is better for the kids. I believe in this. I believe if you practice more, you understand more. If you practice more, you understand more. If you practice more, you understand more. Please keep practicing, and so repeat as much as you can. Now, and also don't forget, if you have our video, to like and subscribe to receive all the new videos from us. Let us see what we have to do. Okay, now number 18, integration of sine 2x. Integration of sine 2x. That's here, just remember here. Integration of sine ax dx, the rule is easy. Cosine, integration of sine is negative. Okay, let me just finish everything. And the derivative here is a, we divide by a. And because this is, you see, the other way is negative cosine, then the answer negative cosine. Then this guy will be negative cosine 2x over what? 2. And I have a limit. My limit from 0 to where? My limit from 0 to 4. I'm going to get my mouse here. My limit from 0 to 4. My limit from 0 to where? 4. To pi over 4, which is mean you plug pi over 4 first, and negative cosine 2 pi over 4, everything over 2 minus, and you plug the 0. Now we're done with the pi over 4 minus, open parentheses, negative cosine 2 times 0 over 2. This one and this 2. Cosine will become cosine pi over 2. Cosine pi over 2 is what? 0. Cosine pi over 2 is what? 0. Cosine pi over 2 equal to 0. Cosine pi over 2 equal to 0. Cosine pi over 2 equal to 0. Now, this will be 0. And this is cosine 0 is 1, but we have negative and negative, plus 1 over 2. The answer is B. The answer is B. Now let me just go to this problem. This is a problem, I'm going to do it in the board. This is a problem, look here, number. This problem. He said minimum. I'm going to try to fit it here. Let me see if I can fit the... in this area. That's the max I have, okay. Okay, let me just try to fit it. Yes, I think I can fit it. He wants the minimum. He wants what? Minimum. Minimum or maximum, I have to find the first derivative. Minimum or maximum, I have to find the first derivative. Minimum or maximum. Now, for the minimum value, then this is my function. I have to find the first derivative. Product rule. Product rule. Product rule. F prime of x equal. I'm going to try to fit it here for you guys. Equal. You leave the first x minus 4 cube, and derive in red this guy. I showed you before how you derive it. You bring the 3 down, 3x minus 1, you drop the exponent, 1 becomes 2, and you derive the one inside, which is 3. We're done with the first one, right? Now we're going to bring this back as is, plus 3x minus 1 cube. You see that? Now we're going to derive which guy? The big guy here, which is 3x minus 4 square. And for the derivative inside is 1. The derivative inside is what? 1. Then I don't have to put 1. I'm gonna put 1 in case if you 1, because the derivative is 1. Now this is the first step to find the minimum. The second step to make that equal to 0, to make all this equal to 0. Look, I have here my Gascon factor, this guy and this guy, right? X minus 4 cubed, then I can pull up what? X minus 4 square out. Okay. I have 3x minus 1 square, 3x minus 1 cube. I can take 3x minus 1 square, right? Then these two, my GCF. And I take my brown color, left here, because x minus 4, 3, right? Only x minus 4. And all this out times 9. Because this already 3x minus 1, 3. 3x minus 1 square, I have it. But we have 3, and this we have 9. A plus now. You like this color? Okay, I will take this color. Okay. In the other side, we have 3x minus, we need 1 only. That's 2. 3x minus 1 only, because we have a square here and here a cube, and this out, and we have only 3. All this equal to 0. We make this equal to 0. Now simplify that guy inside the parentheses, the bracket. X minus 4 square, 3x minus 1 square, 9x minus 36 plus 9x minus 3. Right? 18x, right? Everything's okay here. Then x minus 4 square, right? 3x minus 1 square. And here 9x, 18x, right? Minus 39. 9x plus, okay. Okay. Look how smart this question. Look how smart. I need you to see. Minimum or maximum related to positive and negative of the derivative. Related. This guy, look how smart. This equation, and all of you guys smart. This always positive because it's square. And this always positive because the square. This class is not only for the AP calculus or the calculus. This explaining the meaning of what the derivative and the maximum and minimum increasing. This guy positive, then I will deal only with this guy. This positive does not affect me. You make that equal to 0. And 18 minus 39, 18x equals 0. Solve for x, x equals 39 over 18. Divide by 3, 13 over 6. It's actually, without checking, but I'm going to show it to you as minimum. This 13 over 6 here. If you take, look, forget this guy positive. If you take any value to the right, 1306, or to the left is 0. 0 give you what? If you plug 0 in here, forget this, and this will be negative, and here positive, minimum. Decreasing, increasing, then we have minimum. Okay, this is 19. $18, $19. $18, $19, $22, $21. Okay. Limit as, look here, let us go to 21, 22, 23. I'm gonna give you shortcuts very quickly for the test. The denominator and the numerator have the same degree. You see this guy and this guy the same. Just write both these two guys only. 5x squared negative 11x squared. Since he wants the limit as infinity, we focus on the coefficients of the guys because they have the same degree. Then 5 over negative 5 over 11. Then negative 5 over 11. Since we have the same what? Degree. Okay. 22. It's concave down. Concave down, I have to do what? I left enough space for this because I know I need what to solve it. Concave down mean I have to find the second derivative. Mean I have to find the second derivative, right? Okay. The second derivative. Look here. 1 minus x over x squared, which is what? What x squared, guys? What x squared minus 1, guys? Okay. Somebody telling me factorial. X minus 1, x plus 1. This x minus 1 and this 1 minus x minus 1. I'm going to show you something. A minus b, b minus a equal negative 1. Remember this rule from me. A minus b, b minus 1 is this guy and this guy, they'll cancel each other. They will cancel each other. But the answer will be negative 1. Then we have negative 1 over x plus 1 squared. Okay. I have problem with negative 1. Here I have a hole. Look here, just for pre-calculus. I have hole at, you can see here, no? I'm gonna write it a little bit here. We have a hole at the one we cancel at x equal 1, and we have vertical asymptote at x equal negative 1. These two is not part of my domain. It's not part of my domain. To find if the function concave up or down, y square, no square here. Okay. I have to find this my function f. This is my function f. To find guys the concave down, I have to find the second derivative. It's easy for me to make it negative x plus 1 to the negative 1. To deal with the problem like this. Then okay, let me just do two different colors. I'm going to show you something nice now. Okay, f prime negative 1. We have negative already here, right? And we have negative here. From the negative 1, x plus 1 to the negative 2, which is what, guys? X plus 1, negative 2. This is not what I want. I need f double prime. to find the concavity, if the function concave up or down, if w prime negative 2 x plus 1 to the negative 3 times 1, derivative inside is 1, which is negative 2 over x plus 1 what cube. Good job. This is the only, it's impossible to be 0. The only problem I have negative 1, right? Let me just finish, use this guy a little bit. From this guy here. From this part. We have negative 1, which my whole. Negative 1 is my whole. And if, look here, we have the negative 2 in the top. To the left, take 0. To the left of that, I mean, the 0 is here, right? To the right, take 0. 0 plus 1, test point we call it. 0 plus 1, right? Zero here, plus 1 is 1 cube, negative 2 is negative. Then this guy is what? Negative, which is concave down. If you take negative here, 2, negative 2 here, negative 1. Negative 2 plus 1, negative 1. Negative 1 cube is negative. Negative over negative is positive. Then here is going to be positive. Concave up. One more time. The negative 1 my problem, which is the vertical asymptote from here. Then you take any value to the left, and you take value to the right, you take 0, somewhere here, you plug the 0, 0 plus 1 is 1 cube, negative 2 over, then concave down from negative 1 to infinity. This problem, look here, all what he needs to set up the integration for the area, all what you need. The area equal, it's only the area equal integration from 0 to the 1, the top function, which one top function? Square root of x minus x squared dx. This is 1 second problem. This is 1 second problem. Square root of x minus x squared, which is 0 to 1, which is, my answer is, right? Good. Okay, what this means? This is the definition of the derivative. Definition of what? The derivative. Number 24 is the definition of your derivative, guys. Right? The definition of your derivative. Limit tan 2 pi over 8 plus h. Right? Yeah, this means he wants, look here, this is my function f of x equal tan, what I have here, 2, and all this x, because he replaced it by pi over, right? And he wants me to find f prime of pi over 8. Then always focus, look here, how I took my function, f of x, this is the tan. This is the number 2. All this x, because if you remember the formula, f of limit, f of x plus h minus f of x over h, right? And h goes to the 0. That's the rule. Then find the derivative. Find your derivative here. What derivative f tan? Derivative of tan secant square 2 secant square x at pi over 8, right? Secant square 2x. Then at pi over 8, 2 secant square 2 times pi over 8. Pi over 8. 4. Secant pi over 4. What secant, they just, okay, you know this, the formula, I'm gonna erase it, have more space. But again, limit f of x plus h minus f of x over h. Okay. Now, just secant, you have to know secant is 1 over cosine squared pi over 4. Cosine pi over 4 is what? 2 over square root of 2 over 2 square. Cosine pi over 4. 2 over 2 over square root of 2 when you square it becomes 2 over 4, which is 8 over 2, which is 4. Again, look here, 2 square root of cosine pi over 4 square root, cosine pi over 4 square root of 2 over 2. You square it because of the square. When you square this becomes 2 and this 4. Okay, good. Ln x squared over x. This is u substitution. You take u equal ln x. You take u equal what? U substitution, guys, ln x. Then du over dx 1 over x. I tell my students all the time, cross multiply x du equal dx. You see, cross multiply. Now, I'm going to leave the limit to the end, you know what I mean? I will not touch it. I'm going to finish my problem, I will bring back my limit. Then ln x, we assume ln x equal what? U, then u square over x, and the dx become what? X du, x du. Now easy to integrate u square. U square is u cube over 3. Now bring u as is, ln x cube over 3 from 1 to e. Now start with the top, which is the e, ln e cube over 3, ln 1 cube over 3, ln e is 1, ln e is 1, ln e is 1, 1/3 minus 0. Right? 1/3 minus what? Ln e square here. Ln e what? The square. Okay, I have to erase this guy. Ln e square, which is 2. This becomes 2 ln e cube over 3. Ln 1 is 0. Ln e is 1. Ln e is what, guys? Ln e is 1. 2 times 1 is 2 cube 8 over 3. Okay. Let me see if the other problem. These ones, I'm going to do it next time for you, 26, 27. Thank you and have a nice day.